Hello dear students, welcome to my channel Maths with Panindra. In this session we are going to discuss definite integration. 40 questions we are discussing different models. Let us have a discussion. The first question, if integral 0 to 40 dx by 2x plus 1 equal to log a, then a equal to, see here, integral 0 to 40 dx by 2x plus 1 equal to log a. See, by observing 2x plus 1 derivative is 2, which is not there in the numerator. So, multiplying and dividing by 2 for the given integral, 1 by 2, integral 0 to 40, 2 by 2x plus 1 into dx is equal to log a. So here constant 2 we can take this side and it will becomes f dash of x by f of x into dx. So direct step I am writing, that implies that log mod 2x plus 1 applying the limits 0 to 40, which is equal to 2 into log a. So in place of x upper limit 40, if we substitute log 81 directly, 2 into 40 is 80 plus 1 81 minus log 1 will come, x is equal to 0, log 1, which is equal to 2 log a. So log a minus log b, log a by b, so it will becomes log 81 by 1, 81, which is equal to 2 log a. That also implies that 81 can be written as log 9 square, which is equal to 2 log a. Log 9 square can be written as 2 log 9, which is equal to 2 log a. On both sides 2 to get cancelled. By comparing the values, a is equal to 9. So which is there in the second option. We'll move to the next question. The next question, integral 0 to pi by 2, 200 sin x plus 100 cos x divided by sin x plus cos x into dx. We have one shortcut formula, integral 0 to pi by 2 a sin x plus b cos x divided by sin x plus cos x into dx is equal to a plus b into pi by 4. So exactly the given integral is in this form. So we can write it as integral 0 to pi by 2, 200 sin x plus 100 cos x divided by sin x plus cos x into dx equal to 200 plus 100, in place of a comma b these values are there, into pi by 4, so which is equal to 300 into pi by 4, 4 ones are 475s, which is equal to 75 by pi, 75 pi, which is there in the third option. The next question, integral 0 to 5 x into 5 minus x whole power 10 into dx. So here we have one shortcut formula in intermediate classes or in boards. We have one straight question, integral 0 to a x into a minus x whole power n into dx. Whenever the integral is in this form, we have the answer is a power n plus 2 divided by n plus 1 into n plus 2. So based on this formula, the given question will becomes integral 0 to 5 x into 5 minus x whole power 10 into dx. Observe that here the upper limit and here a, the both should be equal, then only the formula will be applicable. So a value is what here by comparing 5 power, n value is what 10 plus 2, here a is equal to 5 and n is equal to 2, you remember that, divided by, so n is equal to 10, a value is 5, divided by n plus 1 into n plus 2, 10 plus 1 into 10 plus 2, so which is equal to 5 power 12 divided by 11 into 12. 11 into 12. So 5 power 12 divided by 132. So which is there in the third option. 5 power 12 by first option. We'll move to the next question. The next question. Integral 0 to infinity dx by x plus square root of x square plus 1 whole power 5 equal to. So for this question also we have shortcut formula. Integral 0 to infinity dx by x plus square root of x square plus 1 whole power n is equal to n by n square minus 1. So according to the given question, n is equal to what here? 5. So 5 by 5 square minus 1. So 5 divided by 25 minus 1, 5 by 24, which is there in the third option. We'll move to the next question. Integral a to b mod x by x into dx. So we have formula integral mod x by x into dx is equal to mod x. So whenever limits are there, integral a to b mod x by x dx equal to applying the limits a to b, which is equal to, in place of x upper limit, mod b minus mod a. But this answer is not there in our options. So according to the condition is a is less than b is less than 0. So a is less than b is less than 0. That means a is less than 0 and also b is less than 0. We know that mod a is equal to minus a when a is less than 0. Mod b equal to minus b when b is less than 0. So here the case is b is less than 0, mod b will becomes minus b, minus mod a will becomes minus a. So minus of minus a, which is equal to minus into minus is plus, plus a minus b. So a minus b is the right option, which is there in the first. We'll move to the next question. Limit n tends to infinity, sigma r is equal to 0 to n minus 1, n by n square plus r square. This problem is related to limit as integration, limit as sum of integration. See here, first limit n tends to infinity, sigma r is equal to 0 to n minus 1, n by n square plus r square. So first what we have to do is limit n tends to infinity, sigma r equal to n minus 1, n divided by n square, take common from the denominator, it will becomes 1 plus r square by n square. So we can write it as r by n whole square now. So one of the n cancel here, that 1 by n will become outside of the summation. Limit n tends to infinity, 1 by n into sigma r equal to 0 to n minus 1, 1 by 1 plus r by n whole square. After reaching of r by n means we know that it is equal to x. R by n value is x. See how we are going to change the limit in terms of integration. We have the formula limit n tends to infinity, 1 by n summation r equal to 0 to n minus 1 f of r by n is equal to integral 0 to 1 f of x into dx. That means wherever r by n is there, you have to replace with x. That is the reason r by n I wrote as x. So this complete limit n tends to infinity, this will becomes integral 0 to 1. Wherever r by n is there, here you have to replace with x. So 1 by 1 plus x square into dx. We know that integral 1 by 1 plus x square dx is tan inverse x. Applying the limits 0 to 1. So tan inverse 1 minus tan inverse 0. Tan inverse 0 is 0. Tan inverse 1 is pi by 4. Tan pi by 4 is 1 now. So tan inverse 1 is pi by 4. So the answer is pi by 4, which is there in the fourth option. We'll move to the next question. The next question. Limit n tends to infinity. Sigma r equal to r is equal to 1 to n 1 by square root of 4n square minus r square. So here limit n tends to infinity. Sigma r equal to 1 to n 1 by square root of n square take common 4 minus r square by n square. In the next step, here n square we can take outside of the root. Limit n tends to infinity. Here n square we can take outside of the root, it will become 1 by n now. So n into sigma r equal to 1 to n 1 by square root of 4 can be written as 2 square r square by n square. That means r by n whole square. We already discussed that whenever like this form is there, in the previous question r is equal to 0 to 1 it is. R is equal to 0 to n minus 1. But here r is equal to 1 to n. So here also we have formula. Limit n tends to infinity 1 by n sigma r is equal to 1 to n. R is equal to 1 to n is equal to r is equal to 0 to n minus 1. Both are same. F of r by n is equal to integral 0 to 1 f of x into dx. That means wherever r by n is there, you have to replace with x. That is the meaning. So this integral will becomes integral 0 to 1 by square root of 2 square minus x square into dx. We know that integral 1 by root of a square minus x square into dx is equal to sine inverse x. So here sine inverse x by a here, sorry. So sine inverse of x by a value is 2. Applying the limits 0 to 1. So sine inverse of 1 by 2 minus sine inverse 0. So sine inverse of 1 by 2. Sine 30 is 1 by 2. So sine inverse of sine pi by sine 30. So 30 degrees. 30 degrees means pi by 6, which is there in the third option. Now the next question. Limit n tends to infinity 1 by n plus 1 plus 1 by n plus 2 plus and so on plus 1 by 6n equal to. So limit n tends to infinity 1 by n plus 1, 1 by n plus 2 plus and so on. 6n can we write as all are n plus 1, n plus 2 and so on. Can I write like 6n can be written as n plus 5n? We can write it. Suppose 7n is there, you can write as n plus 6n. 3n is there, you can write as n plus 2n. So after this step, limit n tends to infinity. In the previous question, summation is there, sigma. So these bracket values also in terms of sigma you have to write it. So sigma r is equal to 1 to 5n. So See whether it is correct or not, we will check out now. 1 by n plus r. If you put r is equal to 1, you will get 1 by n plus 1. If you put r is equal to 2, 1 by n plus 2. And so on. If you put r is equal to 5n, you will get last term 1 by n plus 5n. So it will be, after that what we have to do here? Similar procedure, I want to here get 1 by n. So how to get it is, limit n tends to infinity, summation r is equal to 1 to 5n. 1 by n I am taking common 1 plus r by n. In the next step 1 by n we can take outside of the sigma. Limit n tends to infinity, 1 by n summation r equal to 1 to 5n. 1 by 1 plus r by n. We know that r by n value is x. So after that we have another formula like limit n tends to infinity, 1 by n sigma r is equal to 1 to np f of r by n is equal to sigma 0 to p f of x, integral 0 to p f of x into dx. Here you have to recognize what is p value. Here np, n is there, p value is 5 now. So we can write it as this above integral as integral 0 to p value is 5 now. We can write it as integral 0 to 5 1 by 1 plus 1 by 1 plus r by n value is x dx. Integral 1 by x is log mod x, we know that again. Log mod 1 plus x. Applying the limits 0 to 5, which is equal to log mod 1 plus 5 minus log mod 1 plus 0. So log 6 minus log 1. Log 1 value 0, otherwise log a by log b. Log 6 we can write it. So log 6, which is there in the fourth option. We'll move to the next question. The next question. Let f of x be a function satisfying f dash of x equal to f of x with f of 0 equal to 1 and g of x be a function that satisfies f of x plus g of x equal to x square. Then the value of the integral 0 to 1 f of x g of x dx equal to. These are the options. F of x be a function satisfying f dash of x equal to f of x. So here condition is given, f of x should be equal to f dash of x. That implies that the function f of x should be e power x. For the function e power x, the derivative as well as the function will be same in the e power x. So we decided that e power x value, a function f of x, we got it. After that condition f of 0 equal to 1. So f of 0 value calculated. Wherever x is there, you have to replace with 0. E power 0, that is equal to 1. So f of 0 value is also 1. G of x be a function that satisfies. So f of x plus g of x is equal to x square. That implies that g of x is equal to x square minus f of x. So g of x is equal to x square minus e power x. G of x value we got it. Now come to the question. Integral 0 to 1. Integral 0 to 1. F of x into g of x into dx. Integral 0 to 1. F of x is e power x. G of x is x square minus e power x into dx. Now integral 0 to 1 e power x into x square into dx, actual multiplication. Integral 0 to 1 e power x into e power x, e power 2x, base or equal power should be added, e power 2x into dx. We know the formulas. Integral e power ax dx is equal to e power ax by a. So the second term is going to get e power 2x by 2. After that, we can apply the limits. And in the first term, we can apply the shortcut formula. So here, integral f of x into g of x. Among these two, this is f of x, this is g of x. Generally, we have to apply here Eilert formula integration by parts. Instead of that, x square and e power x. For this function differentiation, for this function integration, till to get the constant term, you have to do that. X square derivative is 2x. E power x integration is e power x. 2x derivative is 2. Integration e power x is e power x again. 2 constant derivative is 0. E power x integration is e power x. So like this product, you have to do that. So alternatively, plus and minus you have to keep. Plus, minus, plus. So integral e power x into x square dx can be written as x square into e power x square into e power x minus 2x into e power x plus 2 into e power x 0 to 1 minus integral e power 2x is e power 2x by 2. Applying the limit 0 to 1. So throughout this, you can take common e power x. E power x into x square minus 2x plus 2. Applying the limit 0 to 1. Here 1 by 2 can take outside. E power x is equal to 1, substitute e power 2 minus e power 0. So now first upper limit, wherever x is there 1, you have to replace. E into 1 minus 2 plus 2 minus e power 0. Here also e power 1. 0 minus 0 plus 2 minus 1 by 2 into e square minus 1. So which is equal to e into, here plus 2 minus 2 get cancelled, 1 minus e power 0 is 1 minus 2 minus 1 by 2 into e square minus 1. So e minus 2 minus e square by 2 plus 1 by 2. So steps you can take indivisible terms. So e 1 by 2 minus 2. So minus 4 plus 1, that is minus 3 by 2 minus e square by 2. Write in the order accordingly. E minus e square by 2 minus 3 by 2, which is there in the second option. We have the second option. In the second option, e minus e square by 2 minus 3 by 2. So like these questions, which is very important regarding JEE and MSET. So thoroughly. We'll move to the next question. The next question. If integral 0 to infinity x square dx by x square plus a square into x square plus b square into x square plus c square equal to pi by 2 times of a plus b into b plus c into c plus c, then integral 0 to infinity 1 by x square plus 4 into x square plus 9, they are asking. So integral given 0 to infinity x square by x square plus a square, x square plus b square, x square plus c square into dx, which is equal to so pi by 2 times of a plus b, b plus c, c plus c. So now they are asking integral 0 to infinity 1 by x square plus 4 into x square plus 9 into dx. Which is equal to. So what I am going to do is multiplying and dividing by x square for this term. So if you do that x square multiplying and dividing, x square plus 4 into x square plus 9 into dx. So in the denominator, x square can be written as x square plus 0. We can write it. Now you compare these two which are in the same form. A square value 0, b square value 4, c square value is 9. So which is equal to, from this comparison, a is equal to 0, b is equal to b square equal to 4, b is equal to 2, c square equal to 9, c is equal to 3. So pi by 2 times of a plus b, 0 plus 2, b plus c, 2 plus 3, into 3 plus c plus a, that means 3 plus 0, which is equal to pi by 2 into 2 into 5 into 3, which is equal to pi by 4 into 5, 20, 23 is 60. Therefore pi by 60, which is in the first option. We'll move to the next question. The next question. Integral 0 to pi x into f of sin x dx equal to. So to solve this type of problems, you can assume that let I equal to integral 0 to pi x into f of sin x into dx. After that, for this you can apply integral 0 to a f of x dx equal to integral 0 to a f of a minus x into dx, property of definite integration. So wherever x is there, you have to replace with pi minus x according to this formula. So integral 0 to pi minus x, f of sin of pi minus x into dx. Sin of pi minus theta is sin theta, we know that. Integral 0 to pi minus x into f of sin x. After that, split into two integrals here. Integral 0 to pi into dx. So pi constant you can take outside, f of sin x into dx minus x into f of x. So integral 0 to pi x into f of sin x into dx. From equation 1, this is equal to I, since from equation 1. So this value is I we can take this side, minus I equal to pi integral 0 to pi f of sin x into dx. Minus I we can take this side. So 2I equal to pi times of integral 0 to pi f of sin x into dx. But in the options, but they are asking I value, integral 0 to pi x into f of x sin x. So from this, I is equal to 1 by 2, that means pi by 2, integral 0 to pi f of sin x into dx. I means what? Given integral only now. So integral 0 to pi x into f of sin x dx equal to pi by 2 integral 0 to pi f of sin x dx, which is there in the third option. We'll move to the next question. The next question, if f of a plus b minus x equal to f of x, then integral a to b x into f of x dx. So let again integral a to b x into f of x dx equal to. Here we are going to apply one of the integration formula. Integral a to b f of x dx equal to integral a to b f of a plus b minus x into dx. So by using this property, this integral, this is you can take as equation number 1, I equal to integral a to b, wherever x is there, a plus b minus x, we have to write it. So f of a plus b minus x into dx. So now a plus b you can take as one term and actual multiplication after that with x. So it will becomes integral a to b, a plus b into f of a plus b minus x into dx. After that minus integral a to b, x into f of a plus b minus x into dx. Since we have the formula, we have the condition I equal to a plus b constant we can take outside, a plus b into integral a to b f of a plus b minus x into dx minus integral a to b x into f of a plus b minus x. Since f of a plus b minus x is equal to f of x, so in place of this and in place of a plus b plus minus x, we can write as f of x. So I will becomes a plus b into integral a to b f of x minus integral a to b x into f of x into dx. Now from equation 1, this second integral value goes to be I. So minus I equal to a plus b integral a to b f of x. So that implies that minus I, we can take this side, I plus I is 2i, a plus b into integral a to b f of x dx. Even here also dx is there. No? So therefore I equal to a plus b by 2 integral a to b f of x dx. So which is there in the second option? Observe carefully. A plus b by 2 integral a to b f of x dx, which is there exactly in the second option. We'll move to the next question, dear students. The next question. Sigma n is equal to 1 to 10 minus 2n minus 1 integral minus 2n to minus 1 to minus 2n sin power 27x dx plus sigma n is equal to 1 to 10 integral 2n by 2n power 2n to 2n plus 1 sin power 27x dx. In the two terms, we observe that sigma n plus 1, sigma n is equal to 1 to 10 is there. So you can take common from these two. Both are common for these terms. So can I write like this? Sigma n is equal to 1 to 10 integral minus 2n minus 1. So I am taking common minus of 2n plus 1 to 2n minus 2n sin power 27x into dx plus integral 2n to 2n plus 1. So here plus 2n only, dear students, plus 2n only it is plus 2n, it is not minus. Even here also plus, it is plus in sin power 27x into dx. Observe that this is 2n, this is minus of 2n plus 1, this is 2n plus 1, minus 2n plus 1 to 2n and 2n to 2n plus 1. So can we write directly the given integral minus 2n plus 1 to 2n, 2n to 2n plus 1 when function is same? You can write it as sigma n is equal to 1 to 10 integral minus of 2n plus 1 to 2n plus 1 sin power 27x into dx. Here we have the formula in properties of integration. Integral minus a to a f of x dx value is equal to 2 times of integral 0 to a f of x dx when f of minus x is equal to f of x, which is equal to 0 when f of minus x is equal to minus f of x. So based on this property, first we will verify here this is f of x value. So here f of x is equal to sine power 27x. F of minus x I am checking that. Sine power 27 of minus x. Sine of minus x is minus sine x. 27 is odd number. So odd number of times minus is minus only. So minus 27 sine power 27x. So f of minus x is equal to minus f of x. Exactly it is odd function. F of x is odd. Whenever it is odd function, this is odd function, this is even function. Whenever odd function, the integral value goes to be 0. So f of x is an odd function. So the integral value goes to be 0. So therefore, the given problem's answer. So whenever we decided this is even or odd function, the answer goes to be 0 by using this property, which is there in the fourth option. Once we go through that, this is the property. This function f of x is an odd function decided, so answer is 0. We'll move to the next question. The next question, limit x tends to 0, integral 0 to x square sine of root t into dt by x cube. This problem is related to Leibniz formula in integration. See here, what is that Leibniz formula? If you substitute x is equal to 0 directly in the numerator here in the upper limit, 0 to 0 is not possible, so it is not defined. X equal to 0 also 0 by 0 form. Whenever 0 by 0 form we are getting in the limits in first year, we can apply L'Hospital formula. So that is the reason we are going to apply Leibniz formula. What is Leibniz formula? Here I will write that. So whenever you are differentiating the function d by dx with the limits are there, integral phi of x to xi of x, f of t dt in terms of t is there. So the answer is, the formula is f of, in place of t upper limit xi of x you write it, into xi dash of x, whose whatever the function is we are substituting upper limit derivative, minus f of, in place of t lower limit xi of x, phi of x, again whose derivative by dash of x. That's what we have to do in the first step. So now come to the question. Integral limit x tends to 0, x is integral 0 to x square sine root t dt. For the numerator, it is going to apply, this formula is going to apply. See, which is equal to limit x tends to 0 by applying Leibniz formula. This is called Leibniz formula, LEI. So by using Leibniz formula, wherever t is there here, applying the substitute that x square. So sine of root x square into d by dx of x square is 2x minus lower limit sine of 0 root 0, again 0 derivative is 0 only, no, divided by the derivative of denominator x cube derivative is 3x square. So 0 into anything is 0. So 2 by 3 is constant, you can take outside. Limit x tends to 0. First you write 2 by 3 into sine x square, root x square, sine x it will becomes, into x divided by x square. One of the x cancel here. 2 by 3 constant you can take outside. Limit x tends to 0. Sine x by x. In the standard limits, we know that this value is equal to 1 only, no? So 2 by 3 into limit x tends to 0, sin x by x value is 1. So which is equal to 2 by 3, which is there exactly in the second option. So once again I'll explain. whenever we are getting here indeterminate form, so for the numerator you have to apply Leibniz formula. Wherever t is there, you have to replace with upper limit. Sine root t is x square. Into x square you have to differentiate 2x minus lower limit sine root 0. Again 0 derivative is 0 by x cube derivative is 3x square. After that simplification and apply limit formula, we will get the answer. We will move to the next question. Next question. The value of integral minus pi to pi cos square x by 1 plus a power x into dx. So to evaluate these type of problems, you can assume the given integral as I equal to integral minus pi to pi cos square x by 1 plus a power x into dx. You put as equation number 1, and by using the property integral a to b f of x into dx is equal to integral a to b f of a plus b minus x into dx. So I equal to integral minus pi to pi cos square of minus pi plus pi minus x whole divided by 1 plus a power minus pi plus pi minus x into dx. Plus pi minus pi get cancelled. So I equal to integral minus pi to pi cos of minus theta is cos theta whole square. So cos square x divided by 1 plus a power minus x into dx. In the very next step, so a power minus x is 1 by a power x. It will come to the numerator integral minus pi to pi. So a power x into cos square x by a power x plus 1 into dx. You put as equation number 2. I think understand this one. Here a power minus x is 1 by a power x. After taking LCM, then the denominator will become a numerator. So adding 1 and 2. Adding 1 and 2. So I plus I, this side is 2I. Observe that equation 1 and 2, both limits are same and denominator is same. Just you have to add the numerator. So it will becomes integral minus pi to pi cos square x plus a power x into cos square x divided by 1 plus a power x into dx. Take common cos square x minus pi to pi cos square x into 1 plus a power x divided by 1 plus a power x into dx. These two will be cancelled. Cos square x is even function. So integral minus pi to pi cos square x can be written as cos square x. You can write as 2 times of integral 0 to pi cos square x into dx. So 2 get cancelled. I equal to cos square x, integral cos square x. So we didn't have direct formula. Integral 0 to pi 1 plus cos dx by 2. So 2 we can take outside, 1 by 2. Integral 1 into dx is x, applying the limit 0 to pi. Integral cos dx dx sin 2x by 2. So 1 by 2 sin 2x, applying the limits 0 to pi. So 1 by 2 pi minus 0 plus 1 by 2 sin 2 pi 0 sin 0 0. Anyway, total it is 0, it will become 5 by 2. So the given integral I is equal to integral minus pi to pi cos square x by 1 plus a power x into dx is equal to pi by 2, which is there in the third option. We'll move to the next question. The next question, integral 0 to infinity x into e power minus x square dx is the first question here. Integral 0 to infinity x into e power minus x square dx. So put x square is equal to t, differentiate with respect to x, 2x dx is equal to dt. So I want only x dx here. So x dx is equal to dt by 2. Upper limit and lower limit, when x is equal to infinity, t is also infinity. Lower limit, when x is equal to 0, t is also 0. So integral 0 to infinity, in place of x dx, you have to replace with dt by 2. So 1 by 2 e power minus t dt, which is equal to 1 by 2 integral e power minus t. So minus you can take outside, e power t minus t. Applying the limit 0 to infinity, minus 1 by 2 e power minus infinity minus e power minus 0. E power minus infinity means 1 by infinity. Minus infinity 1 by e power infinity minus 1. 1 by infinity value 0. So minus 1 by 2, 0 minus 1. Minus of minus 1 by 2 is plus 1 by 2. Therefore, integral 0 to infinity x into e power minus x square dx is equal to 1 by 2, which is there in the third option. Similarly, we will move to the question number 57, which is there. Same type of question, but little difference is there. Here x square equal to t we have taken now in this question 56. But here the question is integral 0 to infinity e power minus x square dx is root pi by 2. This is given already. But they are asking to calculate integral 0 to infinity e power minus ax square dx. So here in this case ax square equal to ax square equal to t square you take better. So differentiate respect x, a into 2x dx is equal to 2t dt. So 2 get cancelled. I want only dx here. Dx is equal to t by ax into dt. So from here x make as a subject, t by root a will come. T by root a. So limits also same. Upper limit and lower limit when x is equal to infinity, t value is also infinity. Lower limit when x is equal to 0, t value is also 0. So integral 0 to infinity e power minus t square, e power minus t square, ax square equal to t square, no? Dx value t by ax into dt. So x value is what? T by root a only, no? So integral 0 to infinity e power minus t square into t by a into x value is t by root a into dt. So tt get cancelled, root a will become numerator, root a times will be cancelled. So which is equal to 1 by root a integral 0 to infinity e power minus t square into dt. By variable change property, 1 by root a integral 0 to infinity e power minus x square dx. This value is equal to given as root pi by 2 only, no? So 1 by root a into root pi by 2. So we can write it as 1 by 2 into root pi by a, which is there in the fourth option. 1 by 2 into root pi by a. So which is there in the fourth option. So little practice is required for these two questions, dear students. We'll move to the next one. The next question. Integral 0 to pi by 4 square root of 1 minus sin 2x by 1 plus sin 2x. So integral 0 to pi by 4 square root of 1 can be written as cos square x plus sin square x minus sin 2x can be written as 2 sin x cos x. So can I write cos x minus sin x whole square? Similarly, denominator also cos x plus sin x whole square. So ultimately we can write it as cos x plus sin x whole square into dx. Root square cancel. Here there is no case where as plus or minus 0 to pi by 4 means first coordinate plus only. Integral 0 to pi by 4 cos x minus sin x divided by cos x plus sin x into dx. Here we are going to apply integral f dash of x by f of x into dx. Exactly it is in this form only. So log mod f of x. So cos x derivative minus sin x derivative cos x. So log mod cos x plus sin x, applying the limits 0 to pi by 4. So cos log mod log cos pi by 4 1 by root 2 plus 1 by root 2 minus log cos 0 1 plus 0. So log 1 is anyway 0. Log root 2 will come 2 by root 2, which is equal to log root 2. 2 ones are 2 root 2 times. So log root 2 is the right answer, which is there in the second option. We'll move to the next question. The next question, integral root 2 by 3 to root 3 by 3 dx divided by square root of 4 minus 9x square into dx. Now what we are doing is integral root 2 by 3 to root 3 by 3 1 by square root of 4 can be written as 2 square minus 3x whole square into dx. The 3x is equal to t, differentiate respect to x, dx is equal to dt by 3, directly I am writing, and upper limit and lower limit will change. Upper limit, when x is equal to root 3 by 3, the t value will becomes, in place of x root 3 by 3 substitute, so t is equal to root 3 will come. That means 3x cross multiply, 3x is equal to root 3 means t. Upper lower limit, when x is equal to root 2 by 3, so then t is equal to, substitute in place of x root 2 by 3, 3 get cancelled, 2 is equal to root 2. So integral lower limit to upper limit root 2 to root 3 1 by square root of 2 square minus t square into dt by 3. So 1 by 3 you can take outside, which is equal to 1 by 3. Integral 1 by root of a square minus x square means sin inverse x. So sin inverse of t by 2, applying the limits root 2 to root 3, 1 by 3 sin inverse of root 3 by 2 minus sin inverse of root 2 by 2. So that means 1 by root 2. 1 by 3 sin inverse of root 3 by 2. Root 3 by 2 means sin 60 is root 3 by 2. 60 degrees minus sin inverse of 1 by pi by 4. 45 degrees. So 1 by 3 15 degrees. But you have to write in terms of radians. So better to take here pi by 60 degrees means 1 by 3 pi by 3 minus pi by 4, take LCM, 1 by 3 12 LCM, 3 4s 4 3s. So here pi will come, pi by 36, which is there in the first option. Now question number 60 here. Integral 0 to 1 tan inverse x whole cube by 1 plus x square into dx. So integral 0 to 1 tan inverse x whole power 3 into 1 by 1 plus x square. This is f of x whose derivative here only now. It is in the form of, here I am going to apply the formula integral f of x whole power n into f dash of x into dx. F of x whole power n plus 1 by n plus 1. So n is equal to 3 here, which is equal to tan inverse x whole power 3 plus 1 by 3 plus 1, that means 4. 1 by 4, applying the limits, 0 to 1. X is equal to 1, tan inverse 1 minus tan inverse 0 whole power 4. So 1 by 4, tan inverse 1 is pi by 4, tan inverse 0 is 0 whole power 4. So pi by 4 whole power 4 into 4 power 5. So just you have to simplify 4 power 5. So after simplifying this 4 power 5, it will become 1024. So pi by 4 whole power 4 divided by 1024, which is third option. Similarly, you can move to the question number 61. Same procedure here also. Question number 61 here. Integral 0 to 1 sin inverse x whole square into whose derivative is here 1 minus x square into dx. F of x whole power n into f dash of x into dx. So sin inverse x whole power n plus 1, n is equal to 2. 2 plus 1 is 3 by 3. Applying the limits 0 to 1. So 1 by 3 constant you can take outside. Sin inverse of 1 minus sin inverse of 0 whole power 3. So 1 by 3. Sin inverse 1 is pi by 2 minus 0 whole power 3. So 1 by 3 into pi power 3 divided by 2 power 3. So pi power 3 by 8 into 3 24. So pi power 3 by 24, which is there in the first option. So the next question, integral 0 to 1 x cube by 1 plus x power 8 into dx. So here x power 8 can be expressed as x power 4 whole square. After that, put x power 4 is equal to t. Differentiate with respect to x. 4x cube into dx is equal to dt. But proof here, x cube dx is equal to dt by 4. Whenever you are taking assumption, limits will change. Upper limit and lower limit. Upper limit. When x is equal to 1, t is also 1. Why? Because 1 power 1, 1 power 4. Lower limit, when x is equal to 0, t is also 0. Therefore, integral 0 to 1 x cube by 1 plus x power 8 into dx equal to integral 0 to 1. In place of x cube dx, dt by 4 now. So dt by 4 into 1 plus x power 8 can be written as this value is t square. So 1 by 4 integral 0 to 1 1 by 1 plus t square into dt. 1 by 4 tan inverse of t. Applying the limit 0 to 1. 1 by 4 tan inverse of 1 minus tan inverse of 0. So 1 by 4 tan inverse of 1 is pi by 4 minus 0. So pi by 16 is the answer. So which is there in the first option. We'll move to the next one. The next question. Integral 0 to pi by 2 dx by 4 cos square x plus 9 sin square x equal to. We have one shortcut formula. Integral 0 to pi by 2 dx by a square cos square x plus b square sin square x is equal to pi by 2ab. A square equal to 4 means a is equal to 2. B square equal to 9. So b is equal to 3. So pi by 2 into 3, which is equal to pi by 12. So pi by 12, which is there in the first option. Shortcut formula. Even the next question 64 is also a shortcut formula. Integral e 0 to infinity e power minus 4x into cos 3x into dx. I already discussed in the previous sessions. Integral 0 to infinity e power minus ax into cos of bx plus c into dx, which is equal to, whenever cos term is there, you can get the value is equal to a by a square plus b square. Same function, same question. Integral 0 to infinity e power minus ax into sin of bx plus c. So the answer is b by a square plus b square. Now the question is cos. So a by a value is what? If you compare these two, a value is 4 divided by a square plus b square. So 16 plus 9, which is equal to 4 by 25, which is there in the second option. The next question also shortcut formula. We have that integral 0 to pi by 2 a tan x plus or minus b cot x divided by tan x plus or minus cot x into dx equal to a plus or minus b into pi by 4. Suppose in both numerator and denominator, both plus or both minus is there, you can write it as, you can write the values of a and b and then apply the shortcut formula. You will get the answer. So now in the denominator here also minus is there. So integral 0 to pi by 2, a value is 5, b value is 3. So whenever both minus is there, you can write as minus only. A minus b into pi by 4, which is equal to 5 minus 3 into pi by 4, which is equal to 2 pi by 4. So pi by 2. Pi by 2 which is there in the third option. We'll move to the next question. The next question. If integral minus 1 to 4 f of x dx equal to 4 and integral 2 to 4 3 minus f of x dx equal to 7. See here, first you have to write the value of this one. So integral 2 to 4 3 minus f of x into dx is equal to 7. That implies 3 into dx through 3 constant, integral 2 to 4 dx minus integral 2 to 4 f of x into dx is equal to 7. So that implies 3 into integral dx is x, applying the limits 2 to 4. That 7 we can take this side, minus 7 equal to integral 2 to 4 f of x dx. After that 3 into 4 minus 2 is 2, minus 7 equal to integral 2 to 4 f of x dx. That implies integral 2 to 4 f of x dx is equal to 6 minus 7 is minus 1. So integral 2 to 4 f of x dx value is minus 1. Now come to the question. Integral, here one more condition is there. Integral minus 1 to 4 f of x dx is equal to 4. So in minus 1 to 4 means in between 2 is also there, no, minus 1 to 2, 2 to 4. So we can write it as integral minus 1 to 2 f of x dx plus integral 2 to 4 f of x dx is equal to 4. Minus 1 to 2, 2 to 4. Integral 2 to 4 f of x dx value we got it as minus 1. That implies integral minus 1 to 2 f of x dx plus integral 2 to 4 f of x dx value is minus 1 equal to 4. This minus 1 we can take this side. We will get required answer minus 1 to 2 f of x dx is equal to 4 plus 1 which is equal to 5. They are asking to calculate integral minus 1 to 2 f of x dx. That was we are getting now. Minus 1 to 2 f of x dx equal to 5, which is there in the third option. We will move to the next question. Next question. For 67, 68, which both are shortcut formulas. Integral a to b f of cos x by f of sin x plus f of cos x into dx. That means integral a to b f of x, sorry, not dx is there. You can write always b minus a by 2. When we have to write like this, when a plus b should be equal to pi by 2. Here conditions apply. A plus b equal to pi by 2. First you can check that whether it is a plus b pi by 2 or not. Pi by 6 plus pi by 3 is pi by 2 only. So we can write the answer is pi by 3 minus pi by 6 by 2. So again, so pi by 6 Pi by 3 minus pi by 6 is pi by 6 into 1 by 2, pi by 12. So which is there in the fourth option. Similarly, integral 0 to pi by 2, direct question, f of sin x divided by f of sin x plus f of cos x. Whenever like this combination sin and cos integral 0 to pi by 2 is there, the answer is upper limit by 2, so 1 by 2 by 2. So always the answer is pi by 2 by 2 is pi by 4. So the answer is option is second option. Upper limit minus, again you have to apply this formula b minus a by 2. So pi by 2 minus 0 by 2. So 1 by 2. So pi by 4. And in this session we discussed integral 0 to 1. We have again another shortcut formula. Integral 0 to a x into a minus x whole power n into dx equal to a power n plus 2 divided by n plus 1 into n plus 2. So similarly, a is equal to 1 here, n is equal to n only. So this we can write it as a power means 1 power n plus 2 divided by n plus 1 into n plus 2. So 1 power anything is 1 only, no? 1 by n plus 1 into n plus 2. 1 by n plus 1 into n plus 2 can be written as 1 by n plus 1 minus 1 by n plus 2. After taking LCM, this value will come. So which is the second option. The next question. F of x in interval of 0 to 1 some function, 1 to 2 another function. Integral 0 to 2 f of x dx. So integral 0 to 2 f of x into dx can be split into two integrals. Integral 0 to 1 f of x dx plus integral 1 to 2 f of x dx. 0 to 1, that means the function value is x square. 0 to 1 x square into dx. Integral 1 to 2, the function is root x. So here note that integral root x dx is equal to 2 by 3 x power 3 by 2. So integral x square is x power 3 by 3, applying the limit 0 to 1. Integral root x is 2 by 3 into x power 3 by 2, applying the limits 1 to 2. So 1 by 3 minus 0 plus 2 by 3 into 2 power 3 by 2 minus 1 power 3 by 2. So 1 by 3 plus 2 by 3 into 2 power 3 by 2 is 2 root 2 minus 1. Take LCM 1 by 3. 1 plus 2 to the 4. 4 root 2 minus 2. So which is equal to 1 by 3. 4 root 2 minus 1. 1 by 3. 4 root 2 minus 1 which is there in the second option. We'll move to the next question. The next question. Integral minus pi by 2 to pi by 2 sin mod x into dx. See here mod x based on plus x when x is greater than 0 minus x when x is less than 0. So here also minus pi by 2 to pi by 2 we can write it as integral 0 to minus pi by 2 to 0 sin mod x dx plus integral 0 to pi by 2 sin mod x into dx. After that 0 to pi by 2, so the interval will come like this 0 minus pi by 2 plus pi by 2. This is x is greater than 0, this is x is less than 0. So minus pi by 2 to 0, mod x value is minus x. So minus pi by 2 to 0, sin of mod x is minus sin x. Integral 0 to pi by 2. 0 to pi by 2 is x is greater than 0. So mod x value is plus x sin x. Integral 0 to pi by 2 sin x dx. Integral sin x is minus cos x. So minus already there cos x. Applying the limits minus pi by 2 to 0 plus, before that minus you can keep. Why? Because integral sin x is minus cos x, minus cos x, applying the limit 0 to pi by 2, which is equal to cos 0 minus cos pi by 2 is 0, minus cos pi by 2 0, minus cos 0 1. So cos 0 value is 1, 1 minus of minus 1 plus 1, 1 plus 1, which is equal to 2. So 2, integral minus pi by 2 to pi by 2 sin mod x into dx is equal to 2, which is there in the second option. The next question, integral minus pi by 2 to pi by 2 square root of cos x minus cos cube x into dx. So integral minus pi by 2 to pi by 2 square root of cos x, if you take common, 1 minus cos square x into dx. Integral minus pi by 2 to pi by 2 root cos x into sin square x into dx. Root sin square x means mod sin x will come. So minus pi by 2 to pi by 2 root cos x into mod sin x. This is completely even function. How it is even function? Check that mod sin x is even function in the interval minus pi by 2 pi by 2. Root cos x, wherever x is there, minus x you can replace. Root of cos of minus theta is cos theta. So sin of minus x is minus sin x, within mod it will come plus. Anyway, it is even function. So whenever it is even function, 2 times of 0 to pi by 2 root cos x into sin x into dx. So here we are going to apply the formula 2 times of integral 0 to pi by 2 cos x whole power 1 by 2 into sin x. If we assume that f of x is cos x whose derivative is minus sin x, so to get f dash of x here, multiplying and before integration symbol, after integration symbol minus, f of x whole power n into f dash of x into dx. So minus 2 into f of x whole power n plus 1. So cos x whole power 1 by 2 plus 1, that is 3 by 2 by 3 by 2. So it will become anyway 2 by 3. Applying the limits 0 to 1, 0 to pi by 2. So minus 4 by 3 cos pi by 2, 0 minus cos 0 1, 1 power 3 by 2 is 1. So minus into minus is plus 4 by 3. So therefore integral minus pi by 2 to pi by 2 square root of cos x minus cos power 3x into dx is equal to 4 by 3, which is there in the second option. We'll move to the next question. If f of x and g of x are two continuous functions for all x belongs to R, integral minus a to a g of x minus g of minus x by f of x plus f of minus x dx is. This function I am considering capital F of x is equal to g of x minus g of minus x by f of x plus f of minus x. First I am going to check that whether it is even function or odd function by taking the value of minus x in place of x. So g of minus x minus g of plus x by f of minus x plus f of x. Minus, if you take common, you will get it as g of x minus g of x by f of x plus f of minus x. So absolutely it is odd function. Therefore f of minus x is equal to minus f of x. So capital F of x is an odd function. odd function. Whenever it is odd function whose by using the properties of definite integration, integral minus a to a f of x dx equal to 2 times of 0 to a f of x dx. Whenever f of minus x is equal to f of x, that means even function, equal to 0, f of minus x is equal to minus f of x, odd function. So based on this formula, so the answer is 0, odd function. Odd function, the answer goes to be 0. The next question. Integral 0 to 1 4x cube by root 1 minus x power 8 into dx. Integral 0 to 1 4x cube divided by square root of 1 minus x power 8 can be written as x power 4 whole square into dx. So put x power 4 is equal to t, differentiate with respect to x. 4x cube into dx is equal to dt. Whenever you are taking assumption, limits will change. Upper limit when x is equal to 1, t is also equal to 1. Lower limit when x is equal to 0, t is also equal to 0. So integral 0 to 1, this will become dt by square root of 1 minus t square. Integral 1 by root of 1 minus x square is sine inverse x. So sine inverse t, applying the limit 0 to 1, sine inverse of 1 minus sine inverse of 0. So sine inverse of 1 is pi by 2 minus 0, which is equal to pi by 2. So pi by 2, that's the third option. The next question. Integral 0 to pi by 2 cos x by 1 plus sine square x into dx. Here also put sin x is equal to t, suppose. Differentiate with respect to x. Sin x derivative is cos x into dx is equal to dt, which is there in the numerator exactly. So whenever you are taking assumption, limits will change. Upper limit when x is equal to pi by 2. So t is equal to sin pi by 2 is 1. So t value 1. Lower limit when x is equal to 0, t value sin 0 is 0. So therefore integral 0 to 1, lower limit to upper limit, cos x dx value is dt divided by 1 plus t square, again like previous problem. Integral 1 by 1 plus t square is tan inverse t, applying the limits 0 to 1. So tan inverse of 1 minus tan inverse of 0, which is equal to pi by 4 minus 0, which is equal to pi by 4. So which is there in the fourth option. We'll move to the next question. The next question. Integral 0 to pi by 2 cos power 5x into sin 2x. So integral 0 to pi by 2 cos power 5x sin 2x means 2 sin x cos x into dx. So 2 constant you can take outside. Integral 0 to pi by 2 cos x into cos x cos power 6x, that means cos x power 6 into sin x into dx. So if you assume that cos x is f of x whose derivative is minus sin x, but minus sin x is not there. So in the next step, minus 2 into integral 0 to pi by 2 cos x whole power 6 into minus sin x into dx. Why? Because to get the formula form we are writing now. F of x whole power n into f dash of x into dx. So here we are going to apply integral f of x whole power n into f dash of x into dx. F of x whole power n plus 1 by n plus 1. We are applying this formula. So where n is equal to what here? 6 minus 2 into cos x power 6 plus 1 7 divided by 7, applying the limits 0 to pi by 2. So minus 2 into by 7, constant you can take out, cos pi by 2 is 0, minus cos 0 is 1, so minus into minus will be plus 2 by 7, so which is there in the first option. The next question, integral 0 to 1 e power x plus e power minus x dx. First what we have to do is integral 0 to 1 by e power x plus e power minus x is 1 by e power x into dx, you write it. So integral 0 to 1, after taking LCM in the denominator, e power x into e power x whole square, again it will become here, e power x by e power x whole square plus 1 into dx. After that, put e power x is equal to t, then differentiate with respect to x, e power x dx is equal to dt. So lower limit and upper limit when x is equal to 1, t is equal to e. Lower limit when x is equal to 0, t is equal to 1, e power 0 is 1. So therefore integral 0 to 1 e power x by e power x whole square plus 1 into dx can be written as integral 1 to e, lower limit to upper limit, dt divided by e power x dx value is dt by 1 plus t square, that is equal to tan inverse t, applying the limits 1 to e. So tan inverse of e minus tan inverse of 1. So tan inverse of e minus tan inverse of 1 is pi by 4. So tan inverse of e minus pi by 4, which is there in the third option. So integral 0 to 1 tan inverse x dx equal to, so whenever single function we are integrating, that to either log or inverse trigonometry, the another function we can take as g of x as 1. So integral 0 to 1 tan inverse x into dx can be written as tan inverse x into 1 into dx. Tan inverse x is f of x and 1 is g of x. By using integration by parts, we will get it is f of x into tan inverse x into integral g of x, integral 1 into dx, applying the limits 0 to 1, minus integral 0 to 1 f dash of x, tan inverse x derivative is 1 by 1 plus x square, integral 1 into dx whole dx, applying the limits 0 to 1. So integral dx is x into tan inverse x 0 to 1 minus integral dx is x, integral 0 to 1 x by 1 plus x square into dx. To get the formula form, multiplying and dividing by 2 f dash of x by f of x form. So log mod f of x. So 1 into tan inverse of 1 minus 0 minus 1 by 2 into log mod 1 plus x square, applying the limit 0 to 1. So tan inverse 1 is pi by 4 minus 1 by 2 into log mod 1 plus 1 minus log 1 0. So pi by 4 minus 1 by 2 log 2, log 1 anyway 0. So pi by 4 minus 1 by 2 log 2, which is there in the first option. We'll move to the next question. Next question, integral 0 to pi by 2 1 by sin x plus cos x into dx. This type of problems, what we have to do, sin x and cos x in terms of tan x by 2. After the tan x by 2 equal to t, then secant square x by 2 into 1 by 2 dx equal to dt. Like this way you can go. But this is the standard result. You remember that. Integral 0 to pi by 2 1 by sin x plus cos x. Why? Because it is a lengthy one. You remember it is a shortcut formula. Root 2 times of log of root 2 times of log of root 2 plus 1. Like this it will come after rationalizing step by step. First what we have to do, sin x and cos x in terms of tan x by 2. 2 tan x by 2 by 1 plus tan square x by 2. and cos x is equal to 1 minus tan square x by 2 by 1 plus tan square x by 2. After that, put tan x by 2 is equal to t. So dx is equal to 2 dt by 1 plus t square. So upper limit and lower limit also will change. When x is equal to pi by 2, t is equal to 1 tan pi by 4. X is equal to 0, t is equal to 0. So integral 0 to 1 by 2t by 1 plus t square plus 1 minus t square by 1 plus t square into 2 dt by 1 plus t square. After simplifying and all, you will get it is root 2 into log root 2 plus 1, which is there in the first option. You remember as a shortcut formula. I will write it here. This is the shortcut formula. We'll move to the last question in this session. Integral 0 to 1 by 2 e power x into sin inverse x plus 1 by square root of 1 minus x square into dx. By observing sin inverse x is f of x whose derivative is 1 by root 1 minus x square. So now it is in the form of integral 0 to 1 by 2 e power x into f of x plus f dash of x into dx. We know that which is also equal to e power x into f of x. Applying the limits 0 to 1 by 2. So f of x is sin inverse x and f dash of x is equal to 1 by root 1 minus x square. So e power x into sin inverse x 0 to 1 by 2. So first upper limit you can substitute is e power 1 by 2 sin inverse of 1 by 2 minus e power 0 sin inverse of 0 e power 1 by 2. So root e sin inverse of 1 by 2 sin 30 degrees is 1 by 2. So 30 means pi by 6. Therefore, the answer is pi by 6 into root e. The application of integral e power x into f of x plus f dash of x into dx formula. E power x into f of x plus c. This formula we can apply. This is integration in integral e power x into f of x plus f dash of x into dx is equal to e power x into f of x plus c. But limits are there, no need to apply c. Thank you dear students for watching my channel. Please do subscribe and share to your friends and relatives. Thank you. Signing off, Maths with Panindra.